year is 2025 and something extraordinary is happening in the skies above our cities. Electric aircraft aren't science fiction anymore. They are reshaping how we think about transportation itself. But behind every revolutionary EVTOL taking flight lies a manufacturing challenge that's pushing the absolute boundaries of aerospace production. Welcome to our deep dive into the technology that's making mass production of electric aircraft not just possible but profitable. Today, we are exploring automated fiber placement, the game-changing manufacturing process that's turning EVTOL dream into airborne reality. I'm your host, Praveen Luthada, CEO of Addcomposites, and over the next 15 minutes, we'll uncover how companies are solving the biggest challenge in aviation industry. That is, building aerospace quality aircraft at automotive quantities. This is the story of AFP, Solutions for eVTOL Manufacturing. Let's start with what makes 2025 such a critical turning point. For the first time in aviation history, we are seeing regulatory barriers falling simultaneously across multiple continents. The US has granted its first commercial eVTOL approvals. The FAA has streamlined certification process, and this momentum has pushed the UK and China to follow suit with more flexible regulations. This isn't just bureaucratic progress, it's difference between prototype dreams and profitable businesses. Companies that can demonstrate working air taxis are now showing clear paths to cash flow positive operations. The market acceptance is there, the technology is proven, and the regulatory framework is finally catching up. But here's the challenge. To capitalize on this unprecedented opportunity, manufacturers need to scale from building one-off prototype to producing thousands of aircraft annually. And that requires a complete reimagining of how we build flying machines. When you're designing anything that needs to fly, two requirements dominate everything else. It must be incredibly light and it must be incredibly strong. This immediately points us towards composite material, specifically carbon fiber composites that can deliver 40 to 60% weight savings compared to traditional aluminum construction. But here's where the industry hits a massive bottleneck. The vast majority of composite manufacturing today is still manual, labor-intensive work. Skilled technicians handling carbon fiber fabrics or tapes one piece at a time. There is a global shortage of these specialized workers, not just in the United States or Europe, but everywhere, including China. So, eVTOL manufacturers face an impossible equation. They need aerospace-grade quality automotive scale quantities with a workforce that simply doesn't exist at the required scale. The solution? Automated manufacturing that can deliver both precision of handcrafted aerospace component and repeatability of automotive production lines. Enter automated fiber placement or AFP. This technology represents a fundamental shift in how we can manufacture composite structure. AFP systems place continuous fiber tapes with extraordinary precision, whether we are working with thermoset material, thermoplastics material, or dry fiber systems. So overall, this adapts to all the other manufacturing processes around the AFP. But here's what's truly revolutionary about modern automated fiber placement machines. Companies like Addcomposites have developed compact AFP heads that can transform any standard industrial robot into a sophisticated fiber placement machine. We're talking about converting existing robotic infrastructure into aerospace-grade manufacturing systems. This means manufacturers can start their automation journey without massive capital investments. Instead of spending millions on dedicated AFP equipment, they can begin with a $3,000-$4,000 monthly investment literally the cost of a single skilled worker. It's the democratization of aerospace manufacturing technology. The beauty of this approach is its scalability. Start with one robot for prototyping, prove your process, then expand systematically as production demands grows. But AFP technology is just one part of the broader material revolution happening in the aerospace manufacturing. The industry is moving away from traditional thermoset prepreg material that require energy-intensive autoclave curing processes. Instead, we are seeing a massive shift towards thermoplastic fiber placement and dry fiber infusion processes. These eliminates the need for autoclave entirely, while offering something even more valuable: complete recyclability. This isn't just about environmental responsibility, though that's crucial. It's about design freedom. When manufacturers know their materials are highly recyclable and their processes are repeatable, they can take risks with innovative designs. They can iterate rapidly without worrying about catastrophic waste or irreversible material commitments. And with artificial intelligence integration, we are seeing unprecedented quality control and waste reduction. AI-driven systems can predict and prevent defects before they occur, resulting in up to 90% waste reduction compared to traditional manufacturing method. Let's talk about the scale we are targeting here. Traditional aerospace might produce dozens of aircrafts annually, maybe hundreds. EVTOL manufacturers are planning for hundreds to tens of thousands of units per year, depending on the aircraft class and application. We are not just talking about passenger air taxis. The market includes cargo delivery, vehicles, emergency medical transports, and significantly defense application. Military demand alone could drive requirements for 5 to 10,000 units annually per region as countries modernize their defense capabilities. This volume represents a complete paradigm shift. We need aerospace quality at automotive quantities, and AFP technology is uniquely positioned to bridge that gap. The repeatability and reliability of automated fiber placement allows manufacturers to dial in their processes once, then scale to whatever volume that market demands. The key insight is that AFP doesn't just make production faster, it makes it more consistent. Every part meets identical quality standards, whether it's the first unit of the line or the 10,000th. Here's where Addcomposites is fundamentally changing the manufacturing landscape. Traditional AFP implementation required massive capital investment. We are talking about $2 to $5 million for dedicated equipment, plus extensive facility modification. Addcomposites has shattered that barrier. Their compact AFP head technology means the manufacturers can start automated composite production for $3,000 to $4,000 per month. That's equivalent to cost of a single skilled composite technician. Except this automated worker never gets tired, never makes inconsistent layup, and works 24 hours a day. The scalability path is extraordinary. Start small with single robot conversion, prove your process, establish your quality matrix, then expand incrementally. Add more robots, incorporate different AFP configuration for various part geometries, scale up as your production requirements grow. This approach eliminates the traditional barrier to entry that kept advanced manufacturing technologies exclusive to major aerospace corporations. Now, innovative startups and established manufacturers alike can access the same automated production capabilities. Looking towards 2030, we are going to see a complete transformation of the aerospace manufacturing landscape. The companies adopting these technologies today, thermoplastic AFP, AI-driven quality control, automated production systems, they are not just improving their current operations, they are positioning themselves to displace the traditional aerospace giants. New entrants to the EVTOL market will have a fundamental advantage. They are not constrained by legacy manufacturing infrastructure or traditional thinking. They can implement these advanced technologies from day one, building production capabilities that established companies will struggle to match. We're talking about fully automated manufacturing ecosystem where design changes can be implemented rapidly, where quality is guaranteed through AI monitoring, and where production can scale seamlessly from prototype to high volume manufacturing. The question for every aerospace manufacturer isn't whether they can afford to implement these technologies, it's whether they can afford not to. The competitive advantages of accessible, automated, high quality manufacturing is simply too significant to ignore. The future of flight is being manufactured today, and it's more accessible than ever before. With innovations like Addcomposites AFP solution, the technology that once required massive capital investment is now available for cost of a single employee. Whether you are an EVTOL startup preparing for certification, an established manufacturer looking to modernize, or an investor evaluating this rapidly evolving industry, the message is clear. Automated fiber placement isn't just enabling EVTOL revolution, it's making it profitable. The sky isn't the limit anymore, it's the beginning.